Too many alerts and not enough action? It's time to get SaltStack. SaltStack is an intelligent IT automation platform that detects security issues in critical business systems and then actually fixes them. With SaltStack, security and IT teams work together to define custom security policies with certified checks for CIS, DISA-STIGs, and more. You can scan systems for millions of compliance checks in minutes. Remediate compliance and vulnerability issues with powerful automation, all in a single platform. Visit securityweekly.com/SaltStack to learn more. SysDig is the first cloud-native visibility and security platform that eliminates the need for standalone tools like container security and monitoring. Using SysDig's unique data approach, enterprises can solve a variety of visibility and security issues at massive enterprise scale for multi- and hybrid cloud environments. SysDig will enable your organization to scan and block vulnerable images and enforce best practices pre-production, block threats, enforce compliance, and monitor application performance, proactively alert on incidents, reduce MTTR with forensics, and capture detailed audit records, all from a single unified platform. Accelerate your transition to containers and then have confidence in your ongoing operations using SysDig. To learn more, visit securityweekly.com/SysDig.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. Some of you told us that you're overwhelmed by the amount of content we distribute. In an attempt to make it a little easier for you to find what you're interested in, we've created our new listener interest list. Sign up for the list and select your interests by visiting securityweekly.com/subscribe and clicking the button to join the list. You can also now submit your suggestions for guests in our recently released guest suggestion form. Go to securityweekly.com/guests and enter your suggestions. Security Weekly will be at Hacker Halted in Atlanta, Georgia this October 10th through 11th. ECCouncil is offering our listeners a $100 discount to attend the two-day conference. Use discount code HH19SW when you register. We've heard good things about their keynote speaker, Paul Asadorian. He'll be running Linux on the desktop.
Yep, and on the laptop.
And on the laptop. So we also, speaking of Linux, we also, in our previous segment, we had a pretty fun time travel going back to the early 90s, just getting a little bit of history of Linux and even a mention of the PDP-11. Also, we can start off this segment with a little bit of history, only going back to about the 2000s, though. But format strings are back. I found an example of a format string. And this actually is something that led into an RCE, a pre-auth RCE on a Palo Alto device, so against a SSL VPN. The reason this kind of stood out for me was format strings, pretty interesting. I don't see them quite as often anymore, but the write-up for this is really nice, and it's a very good way, if you like reading about and learning about vulnerabilities, how to see some of the details. And in this case, the format string was also pretty clever in the sense of using the payload to figure out, is it vulnerable or not. So the initial probing payload was basically percent bunch of nines C, which essentially is creates a large timing difference for the remote system. So it's a great, in that case of like blind SQL injection or blind and timing based types of vulnerabilities, this was just a really neat one from a technical perspective.
Yeah, I thought what was interesting for me in this article a little bit was they thought it was a 0-day at first because the affected versions are interesting. Version 7.0 is not vulnerable. 7.1, 8.0, 8.1 are vulnerable, and then 9.0 is not. So what changed between 7 to 7.1 to create this whole set of vulnerabilities, and then 9? It's just an interesting, because the way they were testing, they thought they had a 0-day, but no, it looks like it was just a known vulnerability in certain versions.
Yeah, and also kind of interesting for those that are trying to figure out what does, how often or how hard is it to find vulnerabilities, just maybe one of a anecdotal data point, just that people will rediscover vulnerabilities, especially if you don't patch your system. So go learn about how format strings work from this post, but go patch your systems as well. Another interesting but real simple one is just on that supply chain, although this article called it the supply chain because it was in the Python package index. But basically, what this researchers found was a package that had been sitting around since 2017, so close to 2 years, that had been downloaded a couple times. It's always hard to tell what's the difference between the number of downloads versus the number of deployments, and therefore the number of potentially vulnerable systems. But just pointing out that looking for vulnerable dependencies is hard, even when you actually are looking at constrained areas, going just after the NPM database or the Ruby gems, or in this case, the Python package index, that there's always going to be something lurking out there. So being able to introspect and get a manifest, or that bill of materials of what's in your app, is always a good thing.
Yeah, I mean, this to me really, from our last segment, kind of hits home a little bit for me, right? Is we know that as part of the supply chain, we have a lot of these libraries and binaries that are dependencies or embedded in there. And a lot of developers just pull those in without thinking about, is there a vulnerable version or not? It's hard to find some of the stuff through static scanning. But what if I could eliminate the stuff that I don't need in the discussion of the unikernel, and think about how that minimizes the potential impact, right? The supply chain is going to get harder and harder, I think, in the software development lifecycle. And if I can use concepts like unikernels to get rid of things I don't need, that not only helps to simplify my bill of materials and my supply chain, it probably also gives me a heck of a lot more secure code going forward.
But
Absolutely.
So one of the interesting things here, I was thinking about this actually when we were talking about nano VMs, and now it's back here now again. From a attacker point of view, how can I pull this outside of the dev side, right? So this is not going to go away. It's as people use more of these modern languages where you include just a little tiny something simple, you think, and next thing you know, you've got like 40, 50 megs, well, maybe not megs, 400, 500K worth of source files based off of that. Okay, so you can control that on the source side and the dev side if you're doing some type of scanning or, one of the tools out there. What if someone does something a little more interesting where, people, I'm running a new matrix, so I'm usually seeing what JavaScript is trying to be loaded in my browser pages. I'll frequently see either jsdeliver.org or some of these third-party CDNs they're there to help you. Google is doing this. I think Facebook is doing it too. They're there to help you, and instead of you having to package that JavaScript in your web server, they'll happily serve it out to you. And of course, they're definitely not tracking you or anything like that. But what happens if the vulnerability is on that side? It's outside your control. You can't just, make sure you've got that version pinned. Well, maybe you can with the URLs, but so, how can you think about this differently and still possibly have some fun with an exploit there with avoiding that that supply chain?
That's a great point, because it's talking about that unikernels was saying, here's the attack surface that I have most, a heavy influence over, but that supply chain is attack surface that you have a lot less influence over. And I like those, without going too much on a sidetrack on language discussions. But that's one of the reasons I prefer compiled languages, because you can also just compile in what you need. And to a degree, that's kind of what the theme of the unikernels are, versus so that maybe this dependency that has that FTP server, if you're not using actually any of that code, you're not compiling in any of that FTP server, because who needs those? Who needs that headache in this day?
Right. This is a broader issue from a supply chain perspective, because how are you going to stop the malicious committer in an open source project? Right. And that's up. In these open source communities, it's possible that somebody goes rogue and commits code and kind of buries some malicious intent in there. This is a much bigger problem. But if I can eliminate certain libraries and dependencies that either do or don't have the vulnerabilities in them, whatever, regardless, I can start to minimize my attack surface. And I think that's what we need to see more of in this environment moving forward.
Yeah, I think that discussion about how do we start to, we have to address this in a different way as well, as much as this is, that supply chain is not a problem that's going to go away. I dropped these under our learning section rather than actually directly bugs, because they were pretty interesting of different ways to look at vulnerability. So one quick example is the Instagram hack, or a potential hack, I should say, where essentially the researcher was saying, it boils down to the password reset capability. That is, here, submit a randomly generated 6-digit number. It's actually, in the modern day with cloud providers, it's not too hard, meaning it's about what this person was claiming, around $150 to get a few thousand IPs to simply brute force a 1 million digit key space. So, before, the emergence of the cloud, and that before the cloud was basically almost a freemium where anybody can sign up, that, spinning up a couple thousand instances would have been pretty expensive. But now that's so easy that our threat model actually has to change around these types of 6-digit random numbers for password recovery workflows. So I just thought it was kind of interesting from that perspective as we rethink what our assumptions are about the defenses that we're building.
Yeah, well, in the old days, we just took over a university lab and used the lab to do this for us. Now we can just spin up instances in AWS and not have to worry about taking over the university systems. We just pay a little bit of money to Amazon and off we go.
Yeah, poor NASA, poor universities. They've hardened their systems a bit more, luckily. But the other aspect here that I also thought was pretty interesting, and a good tie-in to a conversation we had 2 or 3 episodes ago about Apple's recent iOS and macOS announcements about Bluetooth, was this university group talking about tracking anonymized Bluetooth devices. So what was neat about this is they're saying that here's a purely passive attack. Bluetooth devices are already designed to do the right thing, in the sense of basically randomizing their MAC address, or randomizing the address that is associated with each device. So by rotating that, you can't track a single device over time. However, what these researchers identified is that, sure, that address generation is random, but part of the payload used in these broadcasts, these advertising beacons or advertising messages, has some data in it that tends to be more unique to the device, or more predictable to device. So rather than look at the address, which is going to be changing, look at this other part of the payload. And what they were seeing is that for a Windows device, they were tracking this at maximum tracking time. So for a Windows device, they say you could probably follow someone for about half a day. For an Apple device, you could probably follow somebody for about an hour. Even Fitbit, they looked at that you could follow someone, just because it's very constrained IoT device. You could follow someone there to almost an infinite amount of time. And just to throw it in there to be kind to Android this week, Android wasn't vulnerable to this type of attack, because it didn't have anything within its advertising payloads that could be correlated to those randomly generated beacons, or randomly generated addresses. So that was interesting.
I was expecting you to say that Android couldn't get Bluetooth working without a kernel reboot or a kernel rebuild.
Well, the other way to say that is most people are on the old version of Android anyway, so they're busy upgrading and patching and have different things to worry about. But those are the ecosystem wars that we'll get into those at some other point. But this was really cool, because I thought it was some really neat engineering. A very good type of attack, in the sense that it's purely passive and just sitting with a software-defined radio and watching, what are these devices doing. And I thought this is one of those papers where you actually read the countermeasures, and they are both reasonable and attainable, as opposed to more research needs to be done. And one countermeasure was simply these payloads that were that they were able to correlate with the random address changes, basically synchronize the randomization of the payloads with the randomization of the address. That's one good thing. And there's already, BLE does have something called identity resolving keys, which is a way for paired devices to resolve their random private addresses for each other. So there is also some design consideration within BLE already. So it's more a matter, I think this is not so much a design problem as it is an implementation problem for those Windows and Apple devices.
Yeah, well, it sounds like the Fitbit deployment's the worst of all, and Android's is the best because it's not susceptible to this attack. So, lessons learned here is whatever Android's doing is working. Apple is better because it can only be tracked for an hour. Windows, 4 hours. Fitbit, you've got an implementation problem.
Yeah. Yeah, and especially with Fitbit, there you have that challenge of how do you update? That's that classic IoT problem. How do you have good updates in the field, as well as how do you have good updates that you can attest and can't be compromised or intercepted with malicious firmware either?
Right.
So speaking of, we kind of were starting to veer into these are challenges to develop and work with security on. And I think that's a nice segue into two different articles around DevOps and transformation and how security is working with, or for that matter, not working well enough with DevOps teams. And this is an ongoing theme. But I think the first one point out to is this Forbes article, the Solving Digital Transformation. And I think you had some particularly areas of interest in there, Matt.
Yeah, I mean, the article is interesting to me because this is something I've been talking about for years, right? If we are truly going to solve security in the DevOps space, the integration of security into the DevOps pipeline is going to be important. And that means as security vendors and professionals, we have to think differently. Security cannot stay at the end of the pipeline. We have to figure out how to integrate our tools and the data with the developers as they're developing code, right? This concept of shift left requires us to literally shift our tools, shift our data, shift our mindset to the left. And so in here, Gartner stat, which I think is interesting, right? 15% of development teams in 2017 using DevSecOps will grow to 80% by 2021. That means there is a dramatic shift coming in this space, and there are new security solutions that will intro into the space. There's a number of them that I track today in the space that are really looking at how to move security to the furthest left possible in the overall DevOps process, because this trend will continue, should continue, but it may not be legacy vendors that actually help us solve this problem. It may be new vendors that are thinking this way. So the stats were interesting to me because we're going to continue to see this movement over the next few years, which I think is great, but it's going to be a wake-up call, I think, to a lot of security vendors and security professionals that aren't ready for this yet.
Yeah, and for the security professional side of thing, I think it's definitely going to be a lot more pressure on more security professionals to do programming. In other words, actually write the code alongside the DevOps team, build that empathy to understand what does it actually mean to build an app and actually support it. But another thing that the Forbes article was pretty interesting that spoke out to me too was that other aspect of security professionals is working with those developers on that education and training, because doing security and design phase is that part of that shift left, in addition to the tooling that we can apply there. But this also had a really good sentence in there that resonates with me a lot, that I also repeat, which is use examples of hacks that have taken place in the news, or that are because they're relevant to your tech stack or relevant to your industry, as well as don't be shy about using examples of hacks that have taken place at your own environment. And that could either be a penetration test or even bug bounty. And using those types of examples to say, hey, here's something that went wrong. Let's go through a threat modeling exercise. How would you have done something different? Was this a surprise? Did you know this was already brittle code? Those are great conversations to start to have with that DevOps team to then explore and figure out, how much of this is a design problem, implementation problem? How much of it could have actually benefited from some additional tool? We should have actually had something that was SAST or DAST or even just a basic linter to try to find that problem. So that's one of the things that really stood out for me in this, and try to have that mindset for working with development teams.
Yeah, I mean, there's plenty of good examples out there. Equifax and all the misconfigurations of S3 data bucket leaks, et cetera, right? I mean, there's plenty of examples out there. But it comes down to communication. Security and development need to have these conversations. They need to look at these examples, have a conversation on how to prevent it in their code, and make sure that the right kind of code and security mechanisms are being deployed as you're going through the process. I think the biggest challenge for us, and I think this gets a little bit into the next article, is we're just not having that communication. We're not talking, and to me, that's where everything starts.
You're definitely right. That communication aspect has absolutely been another theme that we've touched on a couple times. And in this GitLab report, one of the things, as an aside, I really liked about it is they kind of break down development, security, and operations in sense of a mission. So development of mission acceleration, security for mission readiness, operations for mission clarity. And I just thought that was at least a nice metaphor to explain and frame what DevSecOps looks like, rather than just say, here is DevSecOps as a buzzword, let's move on. But I think there's a lot of themes that won't be surprising in here in terms of communication, how many people are using CI/CD, how many people are using security. But there were a couple things to comment on. And one thing actually that did surprise me was that lots of people apparently responding to this like working on remote teams, and that remote type of work seemed to improve communication and transparency. So more people were saying they actually know what their peers are doing, possibly because they tend to be over communicating. They tend to be actually documenting, not their code, because no one enjoys documenting code, I believe, but they enjoy documenting what they're working on. Here's my task, here's a design document, and so on. And I thought that was something that was a pleasant surprise, I would say. That's one of the things that stood out from this report.
It's a bit of a force function, huh? Sort of forces you to have to actually not hang out in your own little tiny box and work with others. And I'll have to comment, I think sometimes you can, it always comes down to, can you make something fun or interesting for someone to do? At a previous startup, in the late hours and the nights after 20, 30-hour days, I'd start writing my comments in haiku. And so that would actually make it sort of interesting for me to do. And, one way or another, you got to find something to make it entertaining.
No, absolutely. And that, go ahead, Matt.
No, I was going to say, it's interesting from a remote worker perspective, right? Because if you think about a lot of the startups, they want to get everybody in the same building, right? It's all about, everybody's got to work together and be there together. But maybe that's not the most effective for communication sometimes, the ability to force people to communicate. I've been working remote since, 2009, I think, roughly. Most of my career has been right here in Colorado is where I live, but I've had to do a lot of that remote. I've never seen challenges with remote work, but I know a lot of startups, always want those people in the office. But if this actually helps us with communication, building better code, more secure code, maybe it's a good thing to have some of these startups be a little more distributed. We'll see.
Yeah, I think part of it speaks to the idea that we're abstracting so much. So we've been writing code for a long time. But when we talk about like infrastructure as code or security as code, or so much of your web deployment, your cloud deployment can be a YAML file or some configuration text file. We're actually doing a lot more reading and writing. So maybe that is pretty conducive to Slack, email, the written word, to share some documents and provide feedback on and have these workflows around it. So I can see a lot of great reasons, or imagine a lot of great reasons why that'd be successful. On the other hand, there was one thing that stood out to me that was, of course, security does absolutely need to participate in this. And there were some comments in the report saying, anecdotes from different companies, and anonymous, but saying, nobody here cares about security, or no one's really paying attention to vulnerabilities, or vulnerabilities always take a long time to fix. But one of the comments was around whether security vulnerabilities should be a performance metric. And I'm kind of curious to get your thoughts on this, because to answer from my perspective, just the number of vulnerabilities in your app, I think, is actually a pretty poor metric, and that can actually lead you very far away from where you would want your developers to be focusing. And it can create also some, unfortunately, like, perverse incentives and not be reflective of good security practices in your app.
Yeah, I have the same concern with that metric in general, whether it's application-based or device-based. Number of vulnerabilities is not a good metric by itself. Now, the criticality of the vulnerability on the criticality of the system, which leads more to an indicator of risk, I think are better types of metrics to look at here. And so I'm not a big fan of just pure vulnerability metrics in general anyways, because look, organizations are just overwhelmed with the number of vulnerabilities. But if you can tell me, if you can track and measure vulnerabilities that potentially have high criticality to high critical systems that potentially impact the business, that's a better metric for me to kind of track and handle. In the case of application and making this a performance metric for the DevOps guys, I don't know yet. I mean, I think there are going to evolve some really good metrics. We covered an article a couple weeks ago around metrics from a performance perspective. And one of the ones that was not on the list was some of these vulnerability security type ones. I think there are some that definitely will make sense to track as part of overall performance. But remember, the developers are incentivized really towards the business goals of certain functionality, certain capabilities to continue to grow, which are taking more of the focus, I think, from a metrics performance perspective at this point. I think we will have to add some security ones, but I don't think just sheer vulnerabilities is the right one.
Yeah, not at all. And I think, part of the thing there, so you can always say there's part of this around the example being CVSS and the environmental aspect of it. But I think there's also, and I think some vendors are starting to do this, and you probably covered this last week, Matt, but there's some vendors starting to provide a little bit better, more actionable metrics. But I think as an industry, there's a lot of space to grow there. It's both sides. We're talking about how does an application look from the point of view of how many metrics are in it, but also for the smart employee, right? If he wants to get that bonus, if he starts knocking off a bunch of either false positives or the info level things and say, hey, I cut down our vulnerabilities by 25%, where's my pay raise, right? So it can go both ways. But yeah, it's KPIs. I think I'm a big fan of metrics driven, really anything, and I think there's a lot of room to really do some interesting stuff in that space. So yeah, it'd be interesting to see some both for folks who haven't listened, go back and listen to the podcast Matt's talking about, but also think about what else can you do in this. There's a book, I'm trying to find it, I can't find it on Amazon, that talks about metrics and computer security. It's a good read. If I can track down, I'll get that into show notes.
Yeah, it's finding the right metrics that really incentivize the right behavior in the right way, and certain metrics just aren't going to do it. Right. And vulnerability count's definitely one of them.
Yeah, I think on a positive note, there was thing about application security methods, meaning what were teams using to look for vulns. And that seemed like a pretty interesting numbers as well. So the most in just over 50% were looking at dependency scanning. So right there, that talks to our eternal challenge of supply chain and what's your dependency graph look like. And then it was cloud security, container security, and SaaS in that order, which I thought was pretty interesting and kind of speaks to that idea of clouds, containers. These are the much more modern companies moving into the security space, and not as much the legacy types of vendors. And even a little bit sad, but DAST was down near the bottom. And there could be a couple different reasons for this too, just in the sense of where we're shifting left, and where you can, where you're applying your tooling during the CI/CD process. But that was pretty interesting, because it was, here is where automation is important, and dependency scanning is one of the easiest things in the world to automate. And speaking, rather than that sense of what you were alluding to there, or stating there, Matt, rather than actually getting into counts, you can actually get into impact as well.
Mm-hmm. Yeah, definitely. I'd like to see the dependency continue to go up. It's interesting, cloud security and container security is up there. Container security is interesting when you look at the vendors, right? There's a component of static analysis and dependency scanning that's embedded in there. There is some dynamic runtime stuff in there, but not like a traditional DAST by any sense of the imagination. So it's interesting how they kind of group those buckets, because that's not how I would have logically identified them to be chosen. I would have been a little more specific to understand what of the container security vendor, what functionality were they using? Static analysis, which overlaps into dependency scanning, and or more of the runtime stuff instead of just one big blob. But maybe we'll have to work with the GitLab folks and help them define better market segmentation so we can really understand who's doing what. But with cloud security being high on the list, we still see a lot of misconfigurations on the cloud security side causing data breaches. So if that truly is number 2, we're not doing a very good job at it as a whole from an industry perspective yet.
I think it comes back. Well, I think it's a manifestation there, Matt, of some of the stuff we've been talking about, that the dev side, the ops side has to get more familiar, more used to doing, infrastructure as code. And as they don't have that familiarity yet, what you're seeing is they don't have the understanding to adopt some of those tools. So I think we've said it before, but like what I'm seeing is a vast majority of those, not the security folks, but the people who are running the orchestration itself, they're still just trying to wrap their head around vulnerability scanning and what do we do with this data, and what's sort of going on there. There's definitely a corner that like has sophistication, and they want that more the more advanced software features, but a good portion of the market is just like, they've suddenly got a fire hose coming at them of the basic things from our point of view. And we need to help those guys get up to speed.
Yeah, so my Kubernetes cluster and all the vulnerabilities associated with that is so overwhelming to the ops guys, they're not even thinking about the other stuff yet.
Yeah.
Well, we definitely gave them a lot of stuff to think out in this episode, both in the interview segment and the news. So I want to say thank you again to John and Matt, and thank you everyone for joining us this week. And we're going to see you again next week on Application Security Weekly.